Welcome to our Demo IT Day. This is a recording that was done of a Demo IT session in Melbourne focused on the software-defined data center. It was a joint presentation by EMC and VMware. My name is Matt Zwolensky and I head up pre-sales for EMC Australia New Zealand. So the topic of conversation today is the software-defined data center. I just want to spend a bit of time explaining the whole concept and the transformation that the IT industry is going through in order to achieve this software-defined concept. But before we do that, let me step outside of the data center for the moment and kind of step back and look at the big picture. If you're a technologist like me, you probably grew up thinking not just about IT, but a lot of people in IT want to be pilots or engineers. How's this for an engineering challenge? You're the Wright brothers, and in 1903 you wake up and you read this quote in the New York Times, basically saying, guys, it ain't going to happen. 8 days later, what did these guys do? They went out and they flew, right? Kitty Hawk, they actually flew for 12 seconds and got off the ground, defying what all the scientists of the world were saying was possible at that time. Jump forward 50 years or so, and this is the launch of Qantas. Right, and you'll see the plane in the background. It looks largely like the planes we have today. Right, structurally, it's a fairly similar, albeit dated type plane, but structurally, it's kind of similar to what the aircraft we have today. Jump forward 50 more years, and this is the inside of an Airbus A380. And you can see that the cockpit looks more like a computer data center or operations environment than it does that original aircraft. So we've had three major transformations over the last 100 years or so. And you can see that not only has it changed the way planes are built and the structure of them, but there's been major changes in what aircraft can achieve. Right? A pilot who used to be able to fly one passenger on that original flight at Kitty Hawk, now 2 or 3 pilots can fly 800 passengers for 15,000 kilometers non-stop. But what's astounding is the way that the death rate has changed for flight. Right? For every person that dies today, and think about all the aircraft disaster movies that you've seen, right? 2,000 died back in 1930. So there's a dramatic change or shift in the way this whole industry works. If you think about those transformations, what's the largest investment been? Where's the focus been in the airline industry in terms of research and development and R&D dollars spent? Well, it's largely been, if you think about it, a software platform. You know, I said over the last 50 years, the structure of a plane hasn't changed a lot. You know, maybe the engine's gotten a bit faster, some of the designs have changed marginally, but a lot more of the focus has been on this stuff, right? Fly-by-wire, or the ability to put the plane on autopilot. I was on a flight a couple of weeks ago and the plane hit turbulence. And during that turbulence, you could feel the plane adjusting itself. It wasn't the pilot doing that, it was the plane augmenting against that turbulence. In terms of analytics, a typical flight from Sydney to LA on one flight on an Airbus A380 generates 2 terabytes of information that Airbus uses as analytics to analyze and tune the performance of their craft and their engines. So the industry has been focusing on giving the pilots this software platform, abstracting what they're doing from the control point perspective to the underlying hardware. Right? It's not too dissimilar to what we're going through in the IT industry. And if you think about it, pilots now on these large aircraft, they'd say, I wouldn't fly without this technology. Right? They rely on it day to day. This is not too dissimilar to some of the concepts that we're going to see today in the Demo IT session. Right? So you'll see technologies like vCloud Automation Center, the ability to abstract the way we provision and manage compute and network infrastructure. vPlex, the way we extend our data center to a virtual platform across locations. Or things like automated storage tiering, which is kind of like that turbulence concept, where when the plane was hit with turbulence, it automatically adjusted. Well, unexpected performance changes happen within data centers all the time. And you need some sort of technology that's going to rebalance and change the way your performance and infrastructure is laid out without that human intervention. So let me explain the concept of the software-defined data center. If you think about IT and the physical side of infrastructure, there's really three main components that we've had for the last 30 years. The first is some sort of compute or centralized CPU processing engine. The second is a storage layer, whether that's backup and recovery to tape or the underlying storage infrastructure. And the third is the communications mechanism or the network. Increasingly, what we're finding is that vendors are So let me explain this whole software-defined data center concept and how it's come about. If you think about IT and infrastructure and the physical side of what we do, over the last 30 years, there's really been these three main components to a data center. The first is the compute or server layer, right? The idea of a central processing engine or CPU. The second is some sort of storage infrastructure, whether that's the underlying disk drives and disk technology or the backup platform that's used to protect our data center. And the third is the communications layer or the network. Right, so those three components fundamentally make up pretty much all of what's in a data center that is related to technology and IT. Right, the rest of the stuff is power and cooling. Increasingly, what vendors are finding is that we're coming up with ways to virtualize these devices. Right, so VMware's done a pretty good job of virtualizing the server and compute platform. So we can run multiple virtual machines on one physical server. And they've abstracted the underlying technology, which has had massive benefits to the way we provision, the way we can move data centers, etc. Well, the same things are now happening within the storage and network layer. Right? So vendors are finding ways to virtualize the physical components that were once high-end intelligent storage arrays or networking devices. We're finding ways to abstract the intelligence within those layers. So take network as an example. While we may not necessarily virtualize a router or provide a virtual PC to do networking, what we are finding is that there's ways to virtualize the control plane. So take the way that the routing is done and the communications between devices and virtualize that and abstract it in and closer to this software-defined layer. Same thing's happening with storage. We're finding ways to virtualize appliances that EMC has had. A good example of that is our Avamar backup technology, which is a backup solution that does source-based deduplication as part of the backup process. We've taken this physical appliance and we've virtualized that. It's now built in to VMware, and you can actually download that from VMware's site. It's called VDP, or Virtual Data Protection. And it's a virtualized software-defined device that was once a physical, and still is a physical device that EMC sells. We're doing the same thing for many other EMC platforms, whether that's replication technologies and storage technologies. Now, some of those devices we'll be able to fully virtualize, but others, particularly high I/O devices that support things like transactional databases, the impact of virtualizing those, we think, could be huge. We may not be able to actually fully virtualize the physical devices, at least not with today's technology. But what we can do is abstract the control plane, the way we provision storage, the way we manage it. And if we start to abstract that layer, we can very much automate those capabilities and those provisioning technologies. So that's what the software-defined data center is. It's about turning these physical devices into virtual pools of both network, storage, and servers. Right, so if you think about once you have a virtual compute layer, when you need extra compute for a particular business unit or requirement, you can just go and grab that from the pool. Same with storage, same with networking. Right, that's the transformation that we're going to go through. IT doesn't work like that today. Storage is confined to the LUNs that we provide through some sort of manual process to the physical server. Networking is confined to the way we build our routers and switches. IT today is a very slow-moving concept, but going forward, once we start to abstract the control plane, it'll totally change the way that we provision services to our end users, our application developers, our application owners, etc. So a question I often get asked at this point is, how are EMC and VMware collaborating to build the software-defined data center strategy? And as you may know, VMware has been the leader within the virtualization space, whether that be server virtualization with ESX, or the VMware Cloud Automation Center in terms of provisioning cloud infrastructure, or now with their Nicira acquisition in terms of the networking, software-defined networking space. EMC has had a history of being the leader within the physical information infrastructure space. So things like high-end storage arrays, mid-tier storage, replication technologies for disaster recovery, backup and recovery solutions, and scale-out technologies to store blobs of information. So that's the history or the legacy of EMC in terms of the physical world. But where we're focusing the company is now on the software-defined storage space. So we're looking at how we can take our physical devices, our appliances, and our storage arrays, and where possible, turn those into virtual components. So we announced last year the strategy of virtualizing many of our platforms, and we did that with Avamar and turning that into VDP, I spoke about a moment ago. But the idea is we're now looking critically at how we can take these physical high-end devices and mid-tier storage platforms and turn them into virtual appliances. Now, for some of our technologies, that may be possible, but others, particularly high I/O load type applications, workloads such as transactional databases, email systems, virtual desktops, etc., the latency requirement, the I/O requirement for those, because of that high extreme I/O requirement, we may not be able to virtualize our physical devices. Right? The latency would just kill us. But what we can do is virtualize the control plane, hence the term software-defined data center and software-defined storage. So if we take the way we manage the infrastructure, take the way we've got managed things like VMAX, our high-end storage array, we build a separate portal, a separate capability to automate the provisioning of the infrastructure, automate the management, and simplify it. Right? That's what this whole software-defined strategy is about. And in working with VMware, what we're doing is collaborating to look at how do we build virtual SAN technology? How do we build remote replication technology using some of the intellectual property within EMC? So that's kind of where this whole thing is headed and where the collaboration fits. But ultimately, the two companies are working to build a software-defined capability that supports applications such as Oracle databases, Exchange and SQL Server, ERP systems from SAP, and also those next generation of applications like Hadoop that application developers are starting to build around. Now there's three ways to do this, or three paths to the cloud. Hardware is not going to go away. Our goal is to commoditize the infrastructure, to move the intelligence into the virtual layer. But you're still going to, as an IT organization, you still need to buy platforms. Now there's three ways to do this. The first is you can buy servers from maybe the best of breed service companies like Cisco, storage from EMC, backup solutions, etc., and put this together yourself. Now more and more organizations are saying, you know what, I don't want to be an integrator. I don't want to integrate my own solutions. What I really want is somebody else to have pre-built or pre-designed this for me. And that's where vSpecs comes in, this solution on the right. Leveraging our partners and a set of blueprints that EMC has already built, as a customer you can say, look, I'm rolling out this 1,000-seat virtual desktop solution. Do you have a predefined stack that will meet that requirement? And of course EMC has done the sizing to know what sort of compute power you need, how the hypervisor will fit together, what's the underlying storage capability, how you're going to protect and manage this information. Right, so that's what vSpecs is. It's a blueprint way of bringing together your data center. The next evolution of that, and the area we're seeing more and more customers move towards, is the converged infrastructure, or what we call the VCE, vBlock. So VCE is a company jointly owned by Cisco and EMC. And the idea behind VCE is they take this vSpecs idea and they extend it further. So they take this blueprinted technology and build a very rigid set of predefined appliances running VMware, Cisco Blades, and EMC storage and backup solutions. And these predefined appliances, you can think of them as data center and a rack type solutions, are pre-built by VCE. So the day that you receive one of these racks or these pre-built customized solutions is the day you can power it on, your VMs will be running, your IP addresses will be installed, and the typical time of 6 months to build a data center is now cut down to 1 day. So it's amazing time to market when you're rolling out new infrastructure services. But most importantly is the way it converges the infrastructure. If you think about most companies having separate teams to manage servers, storage, compute, virtual layer, network layer. Because the vBlock is a converged platform with one management tool, one interface to manage the whole lot, we're seeing customers transform the entire way they operate these things. So one person can now develop the skill set to manage all of those different layers. So we're starting to see vBlock managers, where previously people were storage managers or server architects. And those people, their skill sets become converged, which means from an IT perspective, it's a much lower cost way of running your data center. But when we start to move to the software-defined data center world, more and more it's going to become important that our underlying infrastructure technology is converged, because it's too hard for our automated platforms to keep up with different levels of server code, different storage platforms, and automate the provisioning and management of those. But if you have a converged platform where all of the code is standardized and maintained by a company like VCE, then it becomes much easier to build the software layer on top of that for the software-defined data center. So this is where we see the world heading under SDDC. So now we're going to move to the Demo IT day. We're going to continue with the theme of this company idea. We started with airlines, right? Qantas, we talked about planes being kind of like their cloud, right? Qantas aren't concerned how their planes are made as long as they're good enough to run their business and that they can use them to deliver their service to customers. But they don't make their own planes, right? They probably wouldn't do a great job compared to someone like Airbus or Boeing, because the IP for building those things is within those specialized companies for building planes. Qantas's capability is delivering a service. So it's kind of like VCE. Right? VCE is a company that takes the best of breed solutions and converges and builds them together into one platform. Today in this Demo IT, you're going to see us build a company called Acme. Acme is a made-up organization. You'll see the logo through the Demo IT day. But basically, Acme have realized that they need to run their business on SharePoint. Right? So they're going to run this Microsoft SharePoint environment. And what we're going to do through the demonstration is show the software-defined data center capabilities in a cloud-like fashion and how we're going to build this data center for Acme. Manage it, we're going to manage faults, virtualize the environment across data centers. And we'll show you the capabilities that are there today within the software-defined data center from EMC and VMware. So that's it for the opening. After this session, when you've taken it all in, and you'll see a lot of demos and technologies presented to you, the way we connect with our audiences post these events is through this website, demoit.me. So point your browser there. You'll see demos from today and other future events. Thank you for your time. Now let's move to the demonstrations.